set it up. We usually give ourselves 8 feet.
Mm-hmm.
Mark line, start off at 8 feet.
Sure.
And everything's said and done, roller down in there and whatnot. We actually don't use a roller no more, we use a tie tail.
Sure.
And then from there we start our survey, and it's just eyeballing everything, whatever you see. Try to stay away from the fine hairline cracks. In probably 10 years, those hairline cracks will probably be more important for somebody else. We're looking for the little bit bigger stuff that's, getting ready to break.
Sure.
But from when we end and when we come back, you can actually print it out, the survey.
Yeah, I mean, you still have to manually do the coding, so it's not
Okay.
going to be automated coding. Just to clarify that, but
And your coding is going to be something totally different than what we're used to right now, because we're doing pipe graphics. So we're going to switch over to
Granite, yeah.
Granite.
What you'll find is it's actually much easier.
Yeah, I'm familiar with Granite.
Okay.
I came from a city that used to run Granite, so it was
Yeah, I thought
a little bit different.
what we would do is I'd just kind of run through a kind of a brief overview on what the duct system is, its capabilities, so everybody's on the same page.
Right.
And then I can show you briefly here above ground, like how you would get into an inspection. And then we can go back to my laptop so I can actually show you how quickly you can go through a duct video and actually review it.
Okay.
So the biggest difference between duct and the traditional methods that you guys are using now are there's no pan and tilt motors, there's no moving parts and pieces to that camera. So it's just a straight line camera that has a really wide angle view, so you're actually able to capture 360 degrees of that pipe rolling down without stopping. So I'm not going to bore you guys to death with a PowerPoint presentation, but we'll kind of go through it. So essentially, why is a better inspection method needed? You guys probably are inundated with requests to go out and inspect, and always being pushed for more footage. Unless you guys are different than the rest of the United States, right? That's kind of the thing. Is hey, we need you guys to get more footage. So this actually helps you achieve those results. We don't make footage promises. A lot of companies will come in here and say you're going to get 5, 6, 8,000 feet a day with a digital side scanning system. We're a little bit more realist in that you might have traffic control scenarios, you might have high flow lines, especially in the rain, things like that. So generally speaking, we have verifiable numbers that allow you to get 2x to 3x the production increase without working any harder. So your work day is not going to change, it's just the robot itself is going to do more work on your behalf. Okay?
That's cool.
So these are kind of the 4 key problems that most municipalities face, most customers face. Personnel, they want you to do more with less. They got you pulled all over the place. They want you to keep your costs down at every turn. And then having accurate historical records. Like you guys might be better than some, worse than others, but if I were to say I need to see line 1, 2, 3 from 10 years ago,
Right.
how quickly would it be able for you to show me that? And so you were talking about those hairline cracks. They're not a big deal today, but again, in 10 years they might be. So if you had a 360 degree view of that pipe 10 years from now, and you could truly do an accurate comparison to see how much it's fell, it kind of gives you a way to predict, all right, this is probably going to fell in 2 years, 5 years, 7 years. Okay? And then finally, that all goes into making more informed decisions using GIS and things like that to embed into your truck. Okay? So as I mentioned, it's an HD wide angle viewing camera. It captures 360 degrees of the pipe. 0 moving parts and pieces, so that means less maintenance, less upkeep on your camera itself, because you're not having to worry about pan and tilt motors, clutches, things like that inside your mainline camera. Okay. You can still pan and tilt around in the pipe, so if you were inspecting and you did see something that was of a major note, you could still stop and record it like a normal traditional inspection, so you can still actually do both. Go ahead.
One thing I noticed about your camera, it's the sphere, I guess.
Mm-hmm.
There's no protection around that.
You see those forks that are sticking in front of them there? Those forks are actually designed to stick out a little past the dome. So from a roots and debris standpoint, those forks are going to do a good job at pushing that stuff out of the way. There still could be some debris that gets on that lens, but that lens is like a Gorilla Glass composite, so it's not going to easily scratch, it's not going to easily become damaged. And it's designed that the way it's shaped is that if you did get something on it, it should roll off of that lens fairly easily with just from gravity.
What I'm getting at is there's some lines of ours that we try to, like we go into a manhole, we try to get as much from that one manhole as possible.
Sure.
So we'll sit in the middle, we'll shoot downstream, as far as we can go. The line allows us. Bring it back, and we'll go upstream. And if the flow allows us, sometimes we're at a spot where there's a curve. We won't be able to do that with that camera. Because right now, we try to manipulate that camera to get in there. And there's going to be a lot of banging and stuff going on. I don't see that happening with that camera.
I think you'd be surprised.
I mean, what would you suggest doing that? Or
I would proceed with caution, of course, with any camera, because just because you have a pan and tilt camera,
I just
Still
think
got
that,
electronics
I just think
in
that
there.
lens in the front is more scary.
you shouldn't. If you're going around a 22 into another line, or even possibly a 45 into another line, there should never be an opportunity for you to be at such an angle to where you're bumping the front of that lens, just because of the way the camera, when the transporter is going to manipulate. Now, if you're using a non-steerable tractor, I would probably suggest, once that happens, is to go down that manhole and just use your pole to position it.
Right.
So that might be a little different for you. But most
We've
of
done that in the past.
yeah, most of the municipalities running it do exactly that. They want to dump out their whole cable reel if they can. So that won't change for you. The lens might look a little bit more fragile than what you have now, but I can tell you, you're not going to have any issues in terms of, even if you scraped it along the bench a little bit, you're not going to cause damage to that. I mean, it was built in a way that's going to be durable and reliable and sustainable, something that's not fragile that you got to worry about every time you put it into a sewer line. So I think you'll be okay. City of Tampa, we did a 1-year case study with them, and actually in comparison to their regular pan and tilt cameras, their repair cost went down to almost zero. And they're doing the same thing, going around bends, turning it around, going upstream, so you shouldn't really have any problems with that.
Okay.
The biggest issue you're probably going to face, to be honest, is if you're going upstream and the flow level is high,
Right.
you might have to get used to plugging a line. And you might not be doing that now, because since you can't manipulate that view and pan and tilt and look up,
Right.
now the flow is just going to hit that camera. So if you have it put in any type of anti-fog or anti-degreaser on that lens,
Right.
it's going to stick, and then as it flows down, you're going to have that line, and then your video will become somewhat unusable. That would probably honestly be the biggest issue you're going to face with Duck. Okay? Great questions, though.
Specs on that lens, it's like 3/16 thick
Yeah,
glass.
it's not.
Oh.
Yeah.
I've seen it scratched. I haven't seen one broken yet. Doesn't mean it can't happen, but they're pretty stout.
Yeah, I mean, I've dropped one from a good distance and it didn't crack.
Hey, that's something in common.
That stays in this little cabin. What stays in California stays in California. So at this point, it's a proven inspection method. This industry's always been a little slow to adapt to technology, but it's actually something that's been around since 2012. So it's not like it was just released yesterday. So it's going to be something that is a proven and reliable technology at this point. Resolution-wise, you're going to be much clearer than the picture that you have now. Again, no moving parts and pieces, and then you're going to get 3 views of that pipe. So 4 quick steps. Step 1 is going to be exactly what you're doing now. You go up, you set up your transporter for 8-inch, 10-inch, 12-inch pipe, whatever you're running for that day. You put it into the manhole, and you go. Biggest difference for you guys is going to be in step 2 and 3. You're going to complete that entire survey without stopping. So no panning and tilting. You don't have to look at a lateral. You don't have to look at a joint. You just go, collect data.
Right.
Step 3 is where the operator would now enter those observations. So depending on how you guys are set up, you can do it 1 or 2 ways, right? So you could put everything back in the office. If you got a guy on sick leave or, hurt his foot and he can't work in the field, he can do the coding. The other way is you can still do it in the truck. You don't need an extra person to do it. So what City of Tampa does, Monday through Thursday, they go out and just collect data all day. They want Friday to kind of be their free day. So the guy who's on the back of the truck works on the maintenance, gets the transporter set up for the next week, fills up their water, cleans out the truck. Main operator in the front does all the coding for that week. So it's kind of an office day without having to go in the field.
Right.
They'll still go out in the field so nobody bothers them. But that's what they'll do in the field, is kind of clean up and get things taken care of. But there's no right or wrong way. We have other guys that as soon as that line's complete, they'll let the guy in the back bring back the equipment as they're coding it. So by the time, let's say you run out 1,000 feet, guy in the back is handling retrieval for that 1,000 feet, and you're able to sit up there and code all 1,000 feet. So when you get it back, you're completely done. You don't have to touch that survey again.
Cool.
So there's a bunch of different ways you can do it. Okay? Step 4 would be something down the road. You guys might want to integrate your ArcGIS system into Granite, so you have all that mapping data in there.
And that's
So-
probably going to be something that we want.
Okay.
Because right now we got it on our phone. We got GIS on our phones. We're just so lucky that company, the one that does the majority, is right here in Redmond.
Right.
So yeah, we got stuff on our phones.
Awesome.
But it would be nice to see it on this screen as well.
Sure.
So we don't have to reach out, or we don't have to, because right now what we do is we have a tablet with us to look up stuff.
And you're probably manually typing in all that asset data when you go to do an inspection too.
Yeah, a lot of it, some of it's in here as far as like certain things. If you were to click on a line, it's going to tell you what size the pipe is and whatnot. It's already pre-done.
Sure. But in your inspection software, wouldn't you still have to type that in?
Yeah, in the beginning.
So having that integration, you wouldn't have to type any of it.
Right,
You'd
perfect.
just be able to click on the line segment just like you could on your phone,
Right.
and all of it would be there automatically.
Is that Esri?
Yes.
So with what he's showing you there, we're bi-directional partners with Esri. So you'll be able to do everything you see there, you'll see it in your software.
Fellas, this is
How are
our
you, sir?
supervisor.
The big differences with digital side scanning versus traditional are those flat images that are generated. Okay, that's really what's going to save your time. So you could go out. I mean, honestly, if you guys could find a way to put a GoPro on a skateboard and do pipe inspection, you'd probably do it, right? But it's the data that you're getting afterwards, so everybody else can make informed decisions. So these flat images are key. So if you were to imagine taking a pair of scissors at the bottom of that pipe and folding it out flat, that's what the digital image is giving you. So like on this flat image up top here, you can actually see there's a sag because it looks like the pipe size is reducing. But what's really happening is the flow level is increasing in that area in the pipe. And we'll show you some samples after I go through this too. There's another sample of a flat image. You can see you have multiple cracks around the lateral connection there. You're capturing 4 still images every second. Again, high resolution, and you're getting those 3 unique views. So you've got your multi-flat, it's going to be on the left-hand side. You got your regular flat that's at the bottom. That's what you're going to work off of from a coding standpoint. And then finally, you got your video view that you can play it back like a traditional video. There. You got several tools built in. The multi-select tool by far is the most handy. That way, let's say you got 8 laterals on a line. You're used to manually panning and tilting over, looking at it, going in, selecting the observation, repeating that process 8 times. Okay. With this, you got to do it once. You go through, you click on all your laterals. It's going to record all 8 observations like that. In your
Oh,
lateral.
nice.
Okay. And that's really where the time savings comes in. So, a couple more things. It's going to always show you your clock position in the pipe. That also comes in automatically, so when you go to save a lateral or save a defect, clock positions will come in, your distance will come in, so you don't have to worry about that.
It knows it already, right?
It knows it, yeah, knows it exactly. And then also has a measurement tool, where if you weren't sure if it was a 4 or 6 inch lateral, you could measure a lateral, figure that out.
You know how many times we go down the.
Talked about GraniteNet a little bit. It's really got unmatched ease of use, one-click observation coding, so it makes everybody's life easier. One big thing on digital side scanning is the Q system requires no software calibration, no camera calibration. There's some other side scanning systems on the market that there's a significant process because they use multiple cameras versus one. So all that has to be stitched together somehow. And so if you don't go through literally a 60-page calibration procedure, then everything else is off. So you always want to make sure you're looking to get something that no camera calibration is required. Are you guys doing NASCO coding at all?
Yeah, we're using NASCO coding.
Okay. So GraniteNet's NASCO certified. You can use Duck as a NASCO tool, so there's no issues there.
Sorry.
No, please go ahead and take it. And then of course,
Are the codes going to be? Are the codes for Granite going to be mimic?
If you're using NASCO, it'll be exactly the same.
like if you're right now, you've got Tap Factory Active TFA.
Yep.
All that's going to be the same.
Yep.
Yes, sir.
Perfect.
Yeah, it's NASCO version 7, the latest. If NASCO comes out with version 8, we'll move over to version 8. So we stay up to date with them. Great question, though. Unmatched partnerships we talked about with Esri. If you guys have a work order management system like CityWorks or Maximo or anything like
Yeah,
that.
we have that with Esri. Yeah.
Yeah, so we have all that built in too. Okay. And then last thing I'm going to touch on before we go over inspection is we did this 1-year case study with one of my customers, which is the City of Tampa. They've got 1,800 miles of gravity main, and they've got 7 Qs trucks. And so they weren't really sure about the digital side scanning technology back in 2016. They decided to take a chance on it. And so again, we tracked it for an entire year, and over the entire year, day after day, they were averaging a 2.2x increase in production.
Wow.
So it's a huge number. Like I said, it's at the field level, nothing's going to change, but it's just the robot's going to do more work for you. And then, of course, you're going to kind of reduce some of the maintenance and upkeep. The blue is the duck. The gray would be their analog trucks. It's also worth noting that those results were achieved by running the duck truck 6 less days per month. So
Wow.
if they were to run this for the same exact schedule, they would have been through the roof. Okay, so some big changes in numbers. And for Tampa, they keep a lot of detailed records on their maintenance cost on every part and piece on that truck. So for them, we were able to see that the duct system resulted in a 55% reduction in savings for them. And then, so for every 100,000 feet they're inspecting, they're saving 26 grand, which is a lot of money. Okay. Time savings, this was actually 400-foot pipe, 20 observations. Total time investment using traditional methods was 50 minutes. Total time invested using duct was 17. So huge time savings there. And that really comes down to the coating, which we'll get into. A couple customer results. Again, we're not making the production claim that you're getting 5,000 feet a day. I'm not.
Yeah.
I want to be clear on that. But, you know, realistically, you can definitely get 2x over what you're doing now. I'm going to kind of skip through this stuff. And let me just show you a sample here. So this is a 10-inch PVC pipe. You can play it back, as I mentioned, like traditional video. But as an operator, as you're going to go through and code, obviously we want to knock out all the laterals first. Those are recurring observations. So all I'm going to
So
do...
this is us like after we already televised the video coming back,
You
right?
got it.
And okay.
You've already gone. We went out and did the inspections today,
Mhm.
and now we're going to come in and we're going to do the inspection review on this 10-inch
Yep, okay.
PVC. Okay. So you got your multi-flat that I showed you earlier. You can scroll through all 380 feet of pipe. Matter just moving through it with a mouse. You can make these sections larger as well. So if you wanted larger sections
That's awesome.
or smaller, you can make those any size you want.
Like a zoom in, zoom out.
Yep.
How do you know? I'm sorry. How do you know what like how many feet of the pipe you are?
You got your distance indicator along the bottom right
Oh,
here.
okay.
So I can't see that small, but it looks like it go around 28 feet possibly.
Okay, yeah, I see.
So it's like a built-in room with that, huh?
Mhm. Yep. And if I click to that point, you also have your footage here, so 27.1
Oh, okay,
feet.
perfect.
That shows you how fast you were traveling at that time.
Wow.
All these red lines equal the view that you're seeing here. So that's the image that you're viewing.
Okay, that makes
Okay.
sense. Yeah.
So they're all aligned. So